Welcome to Boogie Down Games. Lead programmer here, Misala Ponte. I wanted to make a series of comp sci videos. There seems to be a prevailing pretentious attitude in the STEM fields, especially in comp sci. I guess because it makes a lot of money and drew a lot of elitists, and now the elitists are in there. So this is my way of trying to fix that problem. So today I wanted to go over the Fibonacci sequence. So what is the Fibonacci sequence? The Fibonacci sequence is a series of numbers where we add the previous number to the current number and we get a result. Here's an example. So let's say we start at 0 and 1. So 0 is the previous, 1 is the current, so we add 0 plus 1 equals 1. Now, if we shift it over 1, we move over 1, so 1 plus 1 equals 2, as you see here. 1 plus 1 equals 2. 1 becomes previous, 1 also is the current, and now 2 becomes the result. Now, we're going to say 1 plus 2 equals 3. So 1 plus 2 equals 3. Here we go. So now we're going to shift it over again. So we're going to get 2 becomes previous, 3 becomes the current, and then we add those together, it becomes 5 becomes the result. So how do we do this programmatically? We're going to do it iteratively. The next video will be recursively. So I already set up the function here, and we're using C. So basically, we're going to say we have a function here. It returns an integer, and it takes in an integer. So if n equals 0, return 0. If n equals 1, return 1. And you could do this several ways. You could say if n equals 0, or if n equals 1, return n. But I decided to do it this way because it's easier for people to see. So let's comment that out. So now we need a set of variables to hold the numbers in as we work with it, with the sequence. So previous, as we said here, previous would be start at 0. The current, like we said here, is going to start out at 1. And then the result is 0 because we should always initialize our variables, and I was initializing with 0 or no or whatever. And now we want to iterate through this. So we want to go up to, as we see here, up to the point of 5 spaces. So we want to go 1, 2, 3, 4, and 5. So as we see here, we set up a variable called I. I is going to start at 1. We could start at 0, but I decided to start at 1. And if I is less or equal to n, then increment I. And when we increment, we're going to have to go through this block of code here. And when we're done, return of the result, which is here. So result equals the previous plus the current. And then I want to print out what the result is in this current iteration. And then we're going to say current equals previous, and previous equals the result. So we're just going to say 1 plus 1 equals 1, 0 plus 1 equals 1, and then we're going to shift it over, 1 plus 1 equals 2, and so on. So let's run this bit of code and see what happens. As you see here, we get 1, 1, 2, 3, and 5, like you see here. 1, 1, 2, 3, and 5. So we could easily change this up. Let's say we want to go up to number 10 or number 6. Let's just do one more, 6 times. So we're going to get 1, 1, 2, 3, 5, and 8. Let's see if that's correct. So we get to the last result here. So we say 3 and 5, which 3 becomes the previous, 5 becomes the current. So we're going to say 3 plus 5 equals 8. Okay, is this true? Yes, it is. As you see here, we have 8 right down here, right? Right. So this is it for Fibonacci series in the iterative. See you next time in the next video when we do Fibonacci recursively. Okay, thank you, and remember, inclusive, not exclusive.